Dear students, in this class we can see the construction method of engineering house. As we know, engineering house, the house which are used for engineering application are known as engineering house. Mainly in our syllabus, we have three houses majorly: ellipse, parabola, and hyperbola. The construction method is same for all these three curves. Only there is slight difference between stepwise procedure. Now we can see the construction method of all these curves one by one. First of all, we can see the construction method of ellipse. There are a lot of methods available in construction of these curves, but only we are going to see the eccentricity method only. Only we can have the eccentricity method. In this class, we are going to see the construction method of these curves by eccentricity method only. Eccentricity means basically, there are two centers. It will form the eccentricity, but we have a problem. The data will be given by the question automatically. If the eccentricity means, it will give by somewhat fraction 3 by 4, 2 by 3. Like this, we will have the eccentricity. But we can take an example, a problem. For example, for constructing this curve, we need two basic data. One is focal length, normally will be called as focus distance, focal length or focus distance, normally will be given by millimeter. Somewhat, for example, we can have focus distance as say 50 millimeter. Focal distance is 50 millimeter. Then we need one more data, eccentricity. Eccentricity. Somewhat fraction 2 by 3, 3 by 4. One data will be enough for constructing this curve. But before going to this topic, we have to know the type of eccentricity. If the numerator value is lower than denominator value, this type of eccentricity, you will have the ellipse curve. Suppose 4 by 3, 5 by 4. Eccentricity is like this. I mean, numerator value is higher than denominator value. If there is this type of fraction of eccentricity, the curve definitely will come as a hyperbola. So 2 by 3, 3 by 4, 3 by 4, eccentricity is like this. We can construct the elliptical curve, ellipse. 4 by 3, 5 by 4, like this eccentricity. We will construct the hyperbola curve. Okay, one more question arises. Sir, what about parabola? It means eccentricity for parabola 1. Normally, no eccentricity. So basically, we know we revise 3 topics. If the eccentricity is 2 by 3, 4 by 3, somewhat difference between two curves, 2 by 3, 3 by 4, 4 by 5, like this. It will be getting for elliptical curve. 5 by 4, 4 by 3, like this, we can have hyperbola curve. For parabola, no eccentricity or eccentricity is equal to 1. Okay, we know the basic clearly now. We go for any practical example now. For constructing ellipse and hyperbola, we will have two necessary data. One is focal length f, you can take as 50 millimeter. Eccentricity E, eccentricity, small e, you can for ellipse, you have to take us 2 by 3, 3 by 4. For hyperbola, 4 by 3, 5 by 4 like this. Now we can have the procedure to draw the arcs, but now we can select the eccentricity curve, I mean elliptical curve. So we can take as example as 2 by 3 this value. Okay. So completing these data are able for constructing elliptical curve. Now we go for stepwise procedure to construct this curve. Simply because of species, I can take this two values here. F is 50, focus length, eccentricity 2 by 3, enough. Now we don't bother about the tangent and normal. Initially, we can construct the curve, then we go for now the method of drawing tangent normal. Okay, clearly, now I can explain the construction method of these curves. Initially, we have to draw the vertical line, namely directrix, vertical line, directrix. Then we have to draw the horizontal line, namely axis. Can I for this intersection point as a 0 or O? Normally O. Vertical line, directrix, no dimension for convenient line. Axis, horizontal line.